All right, so we are starting section 1, 2 of our Trig book, and this section talks about angles in relationships and similar angles. So here we're starting with section 1, 2. It's about angles, relationships. Oh, you can't see. And similar triangles. Okay, so first, when we have two lines that cross each other at one point, as we see here, we have two lines crossing each other, and as you see, I have four angles that formed from this crossing, and angles 1 and angles 2 share the same vertex, and that's why they are called vertical angles. And vertical angles are congruent, which means they are of the same measure. Let's look at another case when we have two parallel lines in a plane. This line is parallel to this one. And let's see, there is a third line that crosses these two lines like this. So these two lines are parallel. And this line, the third line, is called transversal. Transversal. Okay, now as we see, we have 8 angles that formed. Angles 1, 2, 3, 4, and 5, 6, 7, and 8. Let's look at some special terminology here and relationship between the angles. So first we have angles that are on the inside. They are called interior angles, and angles like these which are on the outside, and they are called exterior angles. So first let's look at alternate interior angles. Alternate means they are on opposite sides of the transversal line. So for example, we have angle 3 and 6 are alternate interior angles. So we have alternate interior angles. We said they are angles 3 and 6, and angles 4 and 5. And these angles are congruent to each other. We also have alternate exterior angles. And in this case, we said these are the exterior angles. Alternate, so we have 1 and 8, and 2 and 7. 1 and 8. And angles 2 and 7 are congruent. Okay, next we'll look at corresponding angles. Corresponding angles are angles of the same position with respect to each other. I'll try to fix this a little. So we said corresponding angles are angles of the same position with respect to each other. So for example here, I have angles 1 and 5 are corresponding angles. 3 and 7, 2 and 6, 4 and 8. So we said angles 1 and 5, 3 and 7. I also have 2 and 6, and 4 and 8. And also these angles are congruent. So when we say corresponding angles, means they are congruent. I'm trying to fix the camera here. Okay, I think that's better. And lastly, we have same side interior angles. Same side interior angles. So these are angles that are on the same side of the transversal line. So here we have angles 4 and 6 and angles 3 and 5. 4 and 6 and angles 3 and 5. And these angles are supplementary. Which means they add up to 180 degrees. Okay, let's look at an example here where we are asked to find the measure of the angle. Find the measure of each angle. And in this example, we have two parallel lines crossed by a third line. And I know that this angle is 3x plus 2. Well, this angle is 5x minus 40. Okay. So as we said earlier, these are alternate exterior angles, and we also said that alternate exterior angles are congruent, which means they have the same measure. So I can say that 3x plus 2 is equal to the measure of the other angle, which is 5x minus 40. Okay, and I can simply solve by subtracting 3x on both sides. So I'll have 2 equals 2x minus 40, then add 40 to both sides, and that will give me 42 equals to 2x. Next I can divide both sides by 2, I know that x is 21. Now I need to plug in the value of x in each measure of an angle to find the measure of the angle. So 3x, the first one is 3x plus 2, and I know that x is 21, so I'll say 3 times 21 plus 2, that's 63 plus 2 and 65 degrees. So this angle is 65 degrees, and of course this angle will be the same measure, 65 degrees as well. Next, we're going to look at triangles. First, we know that measure of all angles of a triangle has to be 180. So if I have this triangle here, so I know that measure of angle 1, 2, 3 all together has to add up to 180. So measure of angle 1 plus angle 2 plus angle 3 plus 180 degrees. Next, let's look at some types of triangles by their angles. Types of triangles by angles. And here we have 3 types of triangles. The first one, when all angles are less than 90 degrees, and this one is called acute angle. And they are all acute angles, so it's an acute triangle. The next type, when we have one angle that is exactly 90 degrees, and this is a right triangle. Third type, when I have one angle that is greater than 90 degrees. So it's called an obtuse triangle. So here all angles are acute less than 90. Here in the right triangle I have one angle that is right or 90 degrees. And in this type of triangle I have one angle that is greater than 90 degrees. Next, let's look at other types of triangles depending on the measure of their sides. So I say types of triangles by their sides. Okay, again we have 3 types here of triangles. First, when all sides are of the same measure. All sides measure the same length. This is called an equilateral triangle. Equilateral triangle. And in this case, it is also an equiangular. So all angles are of the same measure as well. All sides are of the same length, equilateral. Next, when I have 2 sides that are of the same length, and this is called an isosceles triangle. spell right? Yeah. Isosceles triangle. Only two sides are the same length. And lastly, when none of the sides are of the same length, all sides are different lengths, and that's called a scalene triangle. Here, all sides are different. That's a scalene. Okay? All sides are equal, equilateral. Two sides equal isosceles, all different, scalene. Next, let's look at similar triangles. Let's say I have this triangle and another triangle that is similar to it, and as you notice, they don't have to be of the same size. I mean, they can be of the same size, but they could be also scaled up or down. So similar angles don't have to be of the same size. But the two conditions for two or more than two triangles to be similar is that all angles are congruent. Angles are congruent. And the second condition is sides are proportionate. Okay. Let's look at an example here about similar triangles. And in this example, I'm asked to find x. Here I have two triangles. And I've been told that, so this is triangle A, B, C, and this is triangle D, E, F. And I've been told that angles A is of the same measure to angle D. Angle C is of the same measure to angle F. And of course, angles B is of the same measure to angle E. The lengths of the sides for angle ABC are 24, 32, and 16. And here this is X, and this side is 12. So as I can see, I have all corresponding angles of this triangle is similar to the angles of this, not similar, congruent to the other triangle. So angle A congruent to D, angle C congruent to F, angle B is congruent to E. So these two angles are similar, which means the sides, the corresponding sides are proportionate. So I can set up a proportion and find X. And I'll do that by, so I'll have all information for one triangle on this side. So I'll say, this is how we set a proportion. So I have 16 to 24 should be equal to 12 to x. And now I can solve by cross multiplying. So I have 16x equals to 24 times 12, and I got 16x equals to 288. Next, I can divide both sides by 16. And I'll get that x equals to 18. Okay, that's it for this lesson. We'll see you later.